Good afternoon, everyone, and welcome back. In our last lecture, we talked about the big picture of NoSQL. Today, we're going to get very specific and focus on one of the most popular and important document databases in the world, MongoDB. Modern applications, from social media to the Internet of Things, generate complex, semi-structured data that doesn't fit neatly into the rows and columns of a traditional database. MongoDB was built from the ground up for this new reality, designed for agile development and cloud infrastructures. Our goal in this lecture is to give you a solid foundation for working with it. We'll start with the theory, covering MongoDB's core architectural concepts like documents, collections, and the BSON data format. Then we'll move into a hands-on section where we'll use the official cloud platform, MongoDB Atlas, to deploy your very first database. By the end of this session, you'll understand both the theory behind MongoDB and the practical steps to get started. So let's begin by looking at our plan for today. In the first part, we'll focus on MongoDB's architecture. We'll begin with the most important concept, the document data model, exploring what documents and collections are and what makes them so flexible. Then we'll look at BSON, the high-performance binary format that MongoDB uses to store data. In the second part, we'll shift to practice. I'll give you a brief introduction to MongoDB Atlas, and then we'll walk through a series of hands-on steps using screenshots. We'll cover everything from creating your account and first project to deploying a free tier database cluster. We'll wrap everything up by looking at a summary diagram that connects all these theoretical and practical concepts, giving you a complete picture of the MongoDB ecosystem. Let's get started with the foundation of it all, the document data model. All right, let's dive into the first part of our lecture, the theory behind MongoDB's architecture. The heart of MongoDB, and what makes it so different from a relational database, is its data model. It's built on two simple but powerful concepts you see on the slide: documents and collections. The fundamental building block is the document. You can think of a document as being similar to a row in a SQL table, but it's much more flexible and expressive. It's basically a set of key-value pairs, which should look very familiar if you've ever worked with JSON. This is a huge advantage for developers because it directly matches the objects and dictionaries we use in our code every day, which means less time spent on complex mapping. These documents are then grouped into collections. A collection is simply the equivalent of a table in the SQL world. So, you might have a user's collection or a product's collection, for example. Now, let's take a closer look at what makes the document itself so powerful. Let's dive deeper into what makes a MongoDB document so powerful. There are three key properties we need to understand: its flexible schema, the mandatory ID field, and its ability to embed data. First, the flexible schema, also known as schema on read. Unlike a relational database, MongoDB doesn't force every document in a collection to have the exact same structure. One user document might have a middle name field, and another might not, and the database is perfectly fine with that. This is incredibly powerful for agile development, as it allows your data model to evolve with your application. However, this flexibility means the responsibility for keeping data consistent shifts from the database to your application logic. Second, every single document in a collection must have a unique ID field. This acts as the document's primary key. If you try to insert a document without an ID, the MongoDB driver will automatically generate a unique 12-byte ObjectId for you. This ensures that every document always has a unique identifier. Finally, and perhaps most importantly, is the ability to use embedded data. A document isn't just a flat list of key-value pairs. It can contain nested documents and arrays. This allows you to model complex real-world entities in a much more natural way. For example, a single document for a blog post could contain the author's information and an entire array of comments. This is what allows us to retrieve all that related data in a single query and avoid those expensive database joins. Now that we understand documents, let's talk about the containers they live in, collections. We just mentioned that every document has a unique ID field that functions as its primary key. Let's take a closer look at the default value for this field, the ObjectId. The ObjectId is a 12-byte identifier that is cleverly designed to be unique with a very high probability, even in a distributed system with many servers creating documents at the same time. This is achieved without needing a central server to hand out IDs, which is great for scalability. As the slide shows, its 12-byte structure is made of 3 parts. The first 4 bytes are a timestamp, representing the seconds since the Unix epoch. A neat side effect of this is that your IDs are roughly sortable by creation time. The next 5 bytes are a random value that is typically unique to the machine and the specific process where the document was created. And the final 3 bytes are an incrementing counter, initialized to a random value, which ensures that even if you create multiple documents in the same second on the same machine, each one will get a unique ID. This combination of time, machine identity, and a counter is what gives the ObjectId its power and makes it a fundamental part of MongoDB. Now that we've thoroughly examined the document and its unique identifier, let's talk about where these documents are stored. In collections. Now that we've thoroughly examined the document and its unique identifier, let's talk about where these documents are stored. In collections. A collection, quite simply, is a logical container for grouping documents. You can think of it as the direct equivalent of a table in a relational database. So you would have a user's collection or a product's collection, for example. One of the really convenient features of MongoDB is implicit collection creation. Unlike in the SQL world, where you have to run a create table command before you can insert data, MongoDB doesn't require this. The very first time your application tries to write a document to a collection that doesn't exist, MongoDB just creates it for you automatically. However, there are times when you do want to create a collection explicitly, using the db.createCollection command. You would do this when you need to apply specific advanced configurations. For example, you can enforce schema validation rules to ensure data consistency. You might create a capped collection, which has a fixed size and is perfect for storing recent log data. Or you could set up a time series collection, which is highly optimized for things like IoT sensor data or financial metrics. So we have our documents in our collections. This covers the logical structure. Next, let's look at the highly efficient binary format that MongoDB uses to physically store this data, BSON. Okay, so we've covered the logical structure of MongoDB with documents and collections. But how is this data actually stored on disk or sent over the network? MongoDB doesn't use plaintext JSON for this. Instead, it uses a specialized format called BSON, which stands for binary JSON. The choice to use BSON is a fundamental architectural decision that gives MongoDB 2 major advantages over standard JSON: processing efficiency and a much richer set of data types. First, let's talk about efficiency. BSON is specifically designed to be scanned very quickly by the database engine. Each field in a BSON document is stored with its length in bytes. This means when you query for a specific field, the database doesn't have to read and parse the entire document. It can just read the length of the fields it doesn't need and skip right over them. This makes read operations much faster, especially for large documents. The second major advantage is the extended data type system. As you may know, JSON has a very limited set of data types. For example, it only has one number type. BSON adds support for many types that are critical for a database, like 32 and 64-bit integers, 128-bit decimals for financial calculations, a native date type for proper time-based queries, and the ObjectId we've already discussed. The table on the next slide gives a more detailed comparison of the data types available in JSON versus BSON. As I mentioned, one of BSON's key advantages is its rich type system. This table gives a direct comparison and shows what that means in practice. For numbers, JSON just has a single generic number type. BSON, on the other hand, gives you specific integer types like int32 and int64, and a decimal 128 type, which is crucial for financial applications where you can't have rounding errors. For date and time, JSON has no native concept. You're forced to store them as strings or numbers. BSON provides a native date type, allowing for powerful and efficient date-based queries. For unique IDs, JSON has no built-in mechanism. BSON provides the ObjectId type, which we've already discussed, to guarantee uniqueness in distributed systems. And finally, for binary data like images, with JSON you'd have to encode it as a long base 64 string. BSON has a binary data type to store this raw data much more efficiently. This rich typing, combined with the efficiency of the binary format, is what makes BSON the optimal foundation for MongoDB. This completes our look at the theoretical architecture of MongoDB. Now let's shift to the practical side and talk about the cloud platform we'll be using, MongoDB Atlas. Okay, that concludes the first major part of our lecture, the theory behind MongoDB's architecture. Now we're going to shift from theory to practice and answer a crucial question. Where do we actually run our database? And the answer for us is MongoDB Atlas. Atlas is the official cloud platform from the creators of MongoDB, and it's offered as a database as a service or DBaaS. A DBaaS is a cloud model where the provider takes care of all the hard, time-consuming parts of running a database for you. Instead of you having to worry about provisioning servers, configuring networks, setting up replication for high availability, or scheduling backups, Atlas handles all of that automatically. This is a massive benefit because it abstracts away all that operational complexity, freeing up developers to focus on what they do best: designing their data model and building application features. Best of all, for our purposes, Atlas offers a free tier, also known as an M0 cluster. This provides you with a small database on a shared server that is completely free, with no time limits. It includes access to most of MongoDB's core features, and is the perfect environment for learning and completing all the lab work for this course. The rest of this lecture will be a practical walkthrough, using screenshots from the Atlas UI, to guide you through the process of setting up your own free cluster. Alright, with the theory covered, we're now moving into the practical, hands-on part of our lecture. As you can see from the title, our first objective is to get you set up with your own MongoDB Atlas account. In the next few slides, I'm going to walk you through the entire registration process using a series of screenshots from the Atlas website. We'll go step by step, from the main page to the final email verification. The goal here is for you to watch and understand the flow, so you'll be ready to do it yourself during our lab session. So let's get started with the first step. Okay, let's begin the step-by-step process. This first screenshot shows the main page of the official MongoDB website. Your first action is to find and click the green Get Started button, which is highlighted here. This will initiate the registration process. After clicking it, you'll be taken to a standard registration form. You have two options here. You can either fill in your details manually, or you can use the more convenient option to sign up with your existing Google account. Whichever method you choose, you'll need to accept the terms of service, and then click the Create Your Atlas Account button to proceed. Once you've done that, the system will send a verification email to the address you provided. You'll need to open that email and click the Verify Email button inside to confirm you own the account and activate it. After that, you'll click Continue to move to the next step. After you've verified your email, Atlas will immediately prompt you to set up a critical security feature, which we'll see on the next slide. After you've verified your email, Atlas immediately prompts you to set up a critical security feature, multi-factor authentication or MFA. This is a standard and very important security measure. It means that to log in, you'll need more than just your password. You'll also have to provide a second piece of proof that it's really you, usually a temporary code. As you can see in the screenshot, Atlas offers several recommended methods. For our purposes, the simplest one to start with is email, which is highlighted at the bottom. Please select that option. Once you select email, Atlas will send a one-time temporary code to your registered email address. You'll then need to enter that code on the next screen to confirm. Now, for any real-world project containing sensitive data, setting up robust MFA is a mandatory security requirement. However, for our educational course, this step can be performed at your discretion. After verifying with the email code, the system will suggest more robust methods, but for now you can simply click Continue to move forward. After handling the security setup, Atlas might ask you a few optional questions, which you can safely skip as we move toward the main dashboard. Great, so your account is now created and verified. From now on, when you visit the MongoDB website, you won't be registering, you'll be logging in. Before we move into the Atlas dashboard itself, I want to briefly talk about the login process and an important security concept you'll encounter. When you log in addition to your password, you will be asked for a second piece of information, typically a temporary code sent to your email. This is called multi-factor authentication or MFA. The process itself is very familiar. but it's crucial to understand why it's there. Your password is the first factor, something you know. The temporary code sent to your email is the second factor, something you have access to. Using both makes your account vastly more secure. Even if someone were to somehow steal your password, they would still be locked out of your account because they wouldn't have access to your email to get the temporary code. This is a standard and essential security practice for any professional cloud service, and it's important to understand the protection it provides. So once you've successfully logged in using your password and the temporary code, you will arrive at the main MongoDB Atlas dashboard. Let's take a look at what you'll see there and how to navigate the interface. Okay, so once you've successfully logged in, you will land in the main Atlas dashboard. Before we start clicking buttons, it's really important to understand the fundamental way Atlas organizes your work. And the most important organizational unit, as you can see from the title, is the project. As the lecture notes explain, a project is the primary container for your resources. The easiest way to think of it is as a logical folder for a specific application or task. Everything you build, your database clusters, your security rules, and your user permissions will live inside a project. It serves two main purposes. First, it groups your interconnected databases. For this course, for example, we can have one project for all our lab work. Second, it's the primary level for security. This is where you'll configure network access and manage who has permission to work with the resources inside. When you first log in, Atlas usually creates a default project for you, often named Project 0. On the next slide, we'll take a look at the initial dashboard you're likely to see, and I'll walk you through its key elements. Okay, so after you log in for the first time, you'll see a screen that looks something like this. This is the main dashboard for a project. Before we create our own, it's crucial to understand the three-level hierarchy that Atlas uses to organize everything. The highest level is the organization. As you can see highlighted in the drop-down menu at the top of the screen, we are currently inside Alina's org. You can think of the organization as the main root folder for your entire account. It holds all your projects, users, and billing information. Inside an organization, you have projects. The screen we are looking at is the dashboard for a specific project, in this case, the default Project 0. A project is like an isolated container or a folder for a specific application or task. For this course, we will create a single project to hold all of our lab work. Finally, at the lowest level inside a project, you deploy a cluster. You can see the prompt to create a cluster right in the middle of the screen. A cluster is your actual database. It's the set of servers that runs MongoDB and stores your data. Every cluster must live inside a single project. So, to recap the hierarchy, an organization contains projects, and projects contain clusters. Understanding this structure is key to navigating Atlas effectively. Okay, to see a list of all your projects, you'll first need to navigate to the organization level using the main drop-down menu. This will bring you to a screen that looks like this, the organization overview. As you can see, Atlas has already created a default project for us, named Project 0, which is marked here with the number 1. The dashboard provides a quick summary for each project. It shows you the number of clusters inside it, currently 0 as you can see at 2. It also shows the number of users 3, and teams 4, associated with the project. On the far right, you have the main actions you can take. To start fresh with a clean, properly named project for our course, our first step is to delete this default Project 0. To do that, you would click the trash can icon, which is marked with the number 5. After we've deleted it, we'll use the New Project button, marked as 6, to create our own. Now, deleting a project is a permanent action, so Atlas requires an extra confirmation step to prevent accidents. Let's look at the confirmation window you will see on the next slide. And here is that confirmation window. As I mentioned, because deleting a project is a permanent action, Atlas wants to be absolutely sure you intend to do it. To confirm, you can't just click a button. You must first manually type the full name of the project, in this case, Project 0, into the text field, which is highlighted here with the number 1. This is a common security practice in cloud platforms that forces you to pause and consciously confirm your action, preventing accidental clicks. Only after you have correctly typed the name will the red Delete Project button, marked as 2, become active. Once you click it, the project and all its associated data and backups will be permanently removed. So after you've completed this step and deleted the default project 0, your project list will be empty. We are now ready to create our own project for this course. Before we start creating any resources like projects or clusters, I want to show you a very important part of the Atlas dashboard, the billing section. It's crucial to understand how to check this, so you can be confident you are always using the free resources for this course. As you can see on the screen, this is the main overview for billing. The most important number on this page is the one I've marked with 1, the net month-to-date amount. For our course, we will exclusively use the free tier plan, which has no payments or hidden fees. This means this number should always be $0. I recommend checking this page periodically just to make sure it still says 0. If you ever see a non-zero amount here, it's a sign that you might have accidentally created a resource on a paid plan. If that happens, the solution is simple. You just need to identify and delete that paid resource, and then create a new one, making sure to select the free tier option. Now look over to the right at the section marked with 2, Payment Method. You'll see a large button that prompts you to add a payment method. This is very important. You do not need to add a payment method. You do not need to enter any bank card details to complete the labs for this course. So, think of this page as your financial security panel. Just know where it is and remember the 2 key rules. The amount should be 0, and you don't need to add a payment method. With that important point covered, let's get back to creating our project. Okay, with the default project deleted and our billing check complete, it's time to create our own project by clicking the New Project button. That action will bring you to this screen, the first step in the project creation wizard. As you can see, our first task is simply to give our project a name. In the project name field, marked here with the number 1, you should enter a unique identifier for your project. For our example, I'm using the name my_educational_project, as shown in the screenshot. I recommend you use something simple and clear like this as well. Below the name field, you'll see a section for add tags. As the lecture notes mention, this is an optional feature used by large organizations to categorize their projects. We won't be using this for our course, so you can safely ignore this section. Once you've entered the project name, the next button at the bottom, marked here as 2, will become active. Go ahead and click it to move on to the second and final step, adding members to your project. After naming the project and clicking Next, you'll arrive at the second and final step, add members and set permissions. This screen is where you control who has access to this specific project. The field at the top, marked with the number 1, is for inviting other people to your project by email. This is very useful for team collaboration, but for our individual lab assignments we won't be using this. The most important part of this screen is the section marked with the number 2. You can see that Atlas has automatically added you, the project creator, as a member and crucially, assigned you the project owner role. As the name implies, this is the highest level of privilege within this project, giving you full administrative control to do everything, including creating and deleting databases and managing security. Your only task on this screen is to simply verify that your account has been assigned this project owner role. Once you've confirmed your role, you are ready to finalize the process. Just click the large green Create Project button, marked here as 3. After you click this button, the project will be created, and Atlas will automatically take you to the dashboard for your new project. From there, it will immediately prompt us to begin our next major task, deploying our first database cluster. Okay, with our new project created, Atlas immediately prompts us to take the next and most important step, deploying our first database. Now you'll notice that in the Atlas UI, they don't just say database, they use the term cluster. This is an important distinction. A cluster isn't just a database. It's the entire infrastructure that makes it run reliably. As the lecture notes explain, a cluster is a group of interconnected servers that all work together to run your MongoDB instance. This architecture is fundamental for production-grade systems because it provides 2 key characteristics. First, high availability. If one of the servers in the cluster fails, the others simply take over, and your application continues to run without interruption. And second, fault tolerance. The system is designed to automatically handle failures of individual components without you losing any data. So when you create a cluster, you're not just creating a database, you're creating a complete, reliable, and fault-tolerant system to run it on. With that in mind, let's begin the deployment process. Excellent. After you create your project, you'll be taken to its main dashboard, which you can see here. The left-hand menu has changed, showing you all the options for managing this specific project, from databases to security. But right now, the most important thing is in the center of the screen. Atlas is prompting us to take our next step: create a cluster. As the lecture notes state, the entire deployment process is initiated from this one command. So to begin creating our first database, you'll click the large green plus create button, which I've highlighted here. Clicking this button will take us to the main cluster configuration screen. This next step is probably the most important in the entire process because it's where we will choose between a paid or a free database, so it's very important to pay close attention. Okay, after clicking create, you'll land on this configuration screen. This is a very important step, as this is where we choose between a paid or a free cluster. Now I want you to pay close attention here. By default, Atlas automatically selects a paid plan for you. In this screenshot, you can see the M10 option is selected, which I've highlighted with the number 1. There are a few clear indicators that this is a paid plan. It shows the cost, 8 cents per hour, and there's a blue pay-as-you-go warning right below it, which is marked with the number 2. These paid plans are powerful and designed for real production applications, but they are not what we will be using for this course. It is very important that you do not proceed with this default option, as it can lead to unexpected financial costs. Fortunately, the free option is also on this screen. On our next slide, we will select the correct, free tier plan and continue with our setup. So to avoid any costs, we need to explicitly select the correct plan for our course. On the right side of the screen, you will see the free option, which I've highlighted here with the number 1. This is the one you must select. This plan, also known as the M0 tier, is specifically designed for learning and developing small projects, and it's completely free with no time limits. Notice what happens as soon as you select it. The interface updates and the payment warnings disappear. Instead, you'll see a green confirmation banner, marked with 2, that says, free forever. This confirms you are now in the safe free zone. Now, of course, the free plan does have some technical limitations. You are provided with 512 megabytes of data storage, and you will be using shared CPU and RAM resources. But I want to assure you that these resources are more than sufficient for you to complete all the tasks and lab assignments for this entire course. With the free plan selected, the final step is to configure a few minor details like the cloud provider and cluster name, which we will do on the next screen. Okay, with our free plan selected, we're now at the final configuration screen before we launch our cluster. Let's quickly walk through these settings. First is the cluster name, marked with the 1. You can leave the default name, cluster 0, or change it to something more descriptive. Just be aware that once the cluster is created, you cannot change its name. Next, you have the cloud provider and region, marked as 2 and 3. This is where your database will physically live. For the free tier, the options are limited, so my recommendation is to just leave the default settings. Atlas usually recommends the region that is geographically closest to you to ensure the best speed. Now, over on the right under Quick Setup there are 2 very important checkboxes. Please make sure both of these are selected. Automate Security Setup will automatically configure basic security for US, which is a huge time saver. And Preload Sample Dataset is a fantastic feature that will load your new database with a large set of sample data, which will be very useful for us to practice queries on later. Once all that is set, the final step is to click the large green Create Deployment button, marked as 5. After you click this, Atlas will begin creating your cluster. This process is an instant. It usually takes about 3 to 5 minutes. While the cluster is being built in the background, Atlas will immediately guide us through the automated security setup, which we'll look at next. Okay, as soon as you click Create Deployment, Atlas starts building your cluster in the background. While that's happening, It immediately presents you with this important window to configure your basic security. This is the Automate Security setup that we checked the box for. There are two fundamental security steps here. The first, marked with a 1, is to add an IP address to your allow list. Think of this as a firewall for your database. Only connections from IP addresses on this list will be allowed to reach your cluster. For convenience, Atlas has automatically detected and added your current IP address. So for this step, you don't need to do anything. The second step, marked 2, is to create your first database user. Now, this is a very important distinction. This is not the user you log into the Atlas website with. This is a separate account that your applications will use to connect directly to the database. Atlas has pre-filled a username and generated a strong password for you. And now we come to the most critical action in this entire setup process. You absolutely must save this password now. Atlas shows it to you only once. So your next action is to click the copy button, marked here as 3, open a text editor and paste this password. Save that file in a secure place. Once you have copied and safely stored the password, you can click the Create Database User button, marked here as 4, to complete the procedure. After you create the database user, the window will update to look like this. As you can see, there are now green check marks next to both steps, visually confirming that your IP address has been successfully added to the allow list and that your database user has been created. I just want to remind you one more time. I hope you have that password you copied safely stored somewhere, as we will need it for the final step. It's also worth noting that while we've been configuring security, Atlas has been busy in the background creating our cluster and loading the sample datasets we requested. With the security setup complete, we are now ready for the final step in this wizard, obtaining the connection string. The connection string is a specially formatted URI that contains all the necessary information for your application to connect to the cluster. To get it, you'll click the only active green button on this screen. Choose a connection method. Clicking this will take us to a new screen where Atlas will ask us how we want to connect, offering several options for different tools and programming languages. After clicking Choose a Connection Method, you'll be presented with this screen. Atlas is now asking how you want to connect to your database, and it provides several options tailored for different use cases. Let's quickly go over what these are. The first option, drivers, is the one for us as developers. This is for getting a connection string to use in your application code, in languages like Python or Java. Compass is the official graphical user interface for MongoDB, a desktop app that lets you visually browse your data. Shell allows you to connect through a command line interface, which is a powerful tool for administrators. There are also integrations for tools like VS Code and even an Atlas SQL interface for analysts. Each of these is useful, but for our course, since our goal is to build applications that talk to a database, the primary method is the first one, drivers. So go ahead and click on the drivers option. This will take us to the final screen of the wizard, where we will get our actual connection string. And here we are at the final screen where we will get the key to our database, the connection string. Let's break down what's on this screen. Step 1 is select your driver. Here you need to choose the programming language you'll be using. For our lab work, please select Python from the list. Step 2 conveniently shows you the command you'll need to run to install the necessary driver in your Python environment. And step 3 is the most important part. Add your connection string. This long string is the unique address to our database on the internet. Now you need to pay very close attention here. This string is a template. Notice that it contains a password placeholder. For the connection to work, you must manually replace this placeholder with the actual long password that you copied and saved earlier. So the final critical action is to copy this entire string, paste it into a text editor, replace the password placeholder with your real password, and then save that complete, final string in a secure place. This is the key that you will use in all your future lab assignments. Once you have copied and saved your modified connection string, the setup process is complete. You can click the Done button marked here as 4 to close the wizard. At this point, our cluster is fully deployed, configured, and ready for use. After you click Done, the setup wizard closes, and you are returned to the main project dashboard, which you see here. At this point, the initial deployment and configuration process is fully complete. You now have a live running MongoDB database in the cloud. Let's take a quick look at this screen. You can see your new cluster, named Test Cluster, is now listed. Very importantly, you should see a green indicator that says, Sample Dataset Loaded Successfully. This confirms that the test data we requested has been loaded, and our cluster is ready for us to use. This dashboard also provides access to key management functions. The Connect button is very useful. If you ever lose your connection string, you can click this to go through the wizard again. The View Monitoring button takes you to dashboards with real-time performance metrics. And the Browse Collections button is one we'll be using a lot. It opens a tool called the Data Explorer, which provides a visual interface for looking at and querying your data directly in your web browser. Now that we've walked through the entire practical setup, let's take a step back and look at a summary diagram that ties all of these new concepts together. Okay, we've now gone through the entire process from understanding the theory to deploying a live cluster. To wrap up this practical section, let's look at this summary diagram, which puts all the pieces together and connects what we've learned to what we've just done. Let's start from the outside in. The organization user is you, the real person who registered on the MongoDB website and manages the account. Your account lives within the highest level container, the organization. Inside that organization, we created our own project to act as an isolated environment for our lab work. Within that project, we deployed our cluster, the actual group of servers running our database. And because we preloaded the sample data, our cluster now contains the full hierarchy of databases, collections, and documents. Now let's connect the security parts. The IP access list was configured automatically, acting as a firewall that allows access to the cluster only from your IP address. And the database user is the programmatic account whose password you saved. Its credentials are used in the connection string to authenticate with the cluster and access the data. So, as you can see, this diagram isn't just a theoretical model. It's a direct visual representation of the results of your work. Each element corresponds to a specific action you took to deploy your first database in MongoDB Atlas. With this complete picture in mind, let's move to our final conclusion. And that brings us to the conclusion of our lecture. Let's quickly recap the key takeaways from today's session. On the theoretical side, we started by exploring the core of MongoDB's architecture, its flexible data model built on documents and collections. We also learned why MongoDB uses the BSON format to achieve high performance and support a rich set of data types. Then we moved to the practical side. Following the hands-on guide, we walked through the entire process of deploying a free M0 cluster in the MongoDB Atlas Cloud Platform. We configured its fundamental security settings, including the IP access list and a new database user. And most importantly, we obtained and saved the final connection string, which is the key you'll use to connect your applications to the database. The end result is that you now have a fully configured live database cluster in the cloud, loaded with sample data and ready for you to start building on. And to help you solidify your understanding of today's topics, here are a few key questions to consider. Think of them as a self-check to see if you've grasped the main ideas. As noted on the slide, the full list of questions is available in your lecture notes for a more comprehensive review. If you have any further questions as you review the material, please feel free to reach out via email. Thank you.